Okay. So now, for those of you who are also taking 200, I'm going to read the same article, so you'll have to pretend like you haven't heard it. All right. So all the funny onion things were from historical onion. How many of you were alive in '96? Most of you, right? How old were you? Three? Okay. So, General Motors introduces the new Instant Win airbag. Is everybody familiar with the Onion? So it's like a satirical comedy newspaper dealy thing. So with third quarter sales sluggish and its share of the domestic market down 11% since 1993, General Motors unveiled a new Instant Win airbag contest Monday. The new airbags, which award fabulous prizes upon violent high-speed impact with another car or stationary object, will come standard in all of the company's 1997 cars. Auto accidents have never been so exciting, said GM Vice President of Marketing Roger Jenkins, who expects the contest to boost 1997 sales significantly. When you play the new GM Instant Win airbag game, your next fatal collision could mean a trip for two to Super Bowl 31 in New Orleans or a year's worth of free mobile gasoline. Though it does not officially begin until January 1st, 1997, the airbag promotion is already being tested in select cities with feedback overwhelmingly positive. As soon as my car started to skid out of control, I thought to myself, oh boy, this could be it. I could be a big winner, said Cincinnati's Martin Frelks, who lost his wife but won $50 Sunday when the Buick LeSabre they were driving hit an oil slick at 60 miles per hour and slammed into an oncoming truck. When the car stopped rolling down the embankment, I knew Ellen was dead, but all I could think about was getting the blood and glass out of my eyes so I could read that airbag. It's really addictive, said Sacramento, California resident Majorie Camp, speaking from her hospital bed where she is listed in critical condition with severe brain hemorrhaging and a punctured right lung. I've already crashed 4 cars trying to win those Super Bowl tickets, but I still haven't won. I swear I'm going to win those tickets even if it kills me. Cam said that as soon as she is well enough, she plans to buy a new Pontiac Bonneville and drive it into a tree. GM officials are not surprised the airbag contest has been so well received. In the past, nobody really liked car wrecks, and that's understandable. After all, they're scary and dangerous and sometimes even fatal. GM CEO Paul Offerman said, but now when you drive a new GM car or truck, your next serious crash could mean serious cash. Who wouldn't like that? Offerman added that in the event a motorist wins a prize but is killed, the prize will be awarded to the next of kin. According to GM official contest rules, odds of winning the grand prize, a brand new 1997 Cutlass Supreme, are 1 in 43 million. Statistical experts, however, say that the real chances of winning are significantly worse. If you factor in the odds of getting in a serious car accident in the first place, approximately 1 in 720,000, the actual odds of winning a prize each time you step in your car is more like 1 in 31 trillion. Further, even if one is in an accident, there is no guarantee the airbag will inflate. I was recently broadsided by a drunk driver in my new Chevy Cavalier, said Erie, Pennsylvania resident Jerry Polliner, whose car was totaled, and because it was a side of his car that got hit, my airbag did not inflate. But what really gets me is the fact that the drunk driver who rammed my side with the front of his '97 Buick Regal won a $100 Office Depot gift certificate. That's just wrong. All right, so that's your onion for the day. On, what's today, Thursday? On Tuesday, we'll do Chrysler recalls the neck belt safety device. I have a lot of trouble making it through that one without laughing so hard I'm crying. That's probably the funniest one I've ever read. Yeah, so it's some good stuff. And then to get my Christian world viewpoints, at some point we'll have to read the Jesus Christ Returns to the NBA. All right, somebody want to get the front lights, please? Class is 300. Oh, we're just continuing 250, right? Is that our MO? Modified. Uh-oh. Yesterday. Boom, boom. Keep. Hope for the best. Raise. Oh, so we were talking about raise last time, right? And then we bumped into link list. Okay, got it. Got it. All right. So, quick little review, dealy flippy. We like arrays because they're fast. Because they're contiguous in memory. We don't like them because we have to know how much they need to store ahead of time. We also don't like them because they're memory inefficient. Why are they memory inefficient? Because they're contiguous in memory. So this is our pivot point for things that we like and things that we dislike. Because they're contiguous, they're fast, but because they're contiguous, they're memory inefficient. Make sense? Okay. Now, so before I segue into linked lists, where did this crap come from? Whatever. Before I segue into linked lists, sometimes in other classes I don't realize I'm in the wrong lecture set and I just start randomly doing it. It doesn't matter. Oh man, have you guys been following the Sochi Olympics crap?
Mm-hmm.
Sochi Olympics, is that how you say it? Sochi? How many of you don't know what I'm talking about? All right, so the Olympics start tonight, right? The Winter Olympics, and it's in Russia. And, Russia is a fairly poor country. They're a big country with a strong military, but they don't, it's like a third world country anymore. And so they didn't have any infrastructure in this town where they're having the Olympics. So they've had to build the hotels and all this. None of it's ready. Okay, so the media, and there was all sorts of, rumors about this leading up to the Olympics, but now the media are starting to show up, and they're tweeting about this. They're showing, they're being told that the water coming out of the faucets isn't even safe to bathe in. And I think CNN or something had 14 rooms reserved, and only one of them is ready. The other ones are still being built in this hotel. So they'll walk outside their door, and they'll see construction workers and also stray dogs. Apparently there's a dog problem in Sochi, going in and out of different rooms and stuff like that. Some of the rooms don't have doors on them. There's one picture of a bathroom where it says, "Please do not flush toilet paper down toilet. Please dispose of it in wastebasket." They give you a trash can. Another person, it was actually pretty funny. I think this was just this morning. Said, "I've come into possession of 3 light bulbs." This is some journalist. "Will trade for a door handle." Then hashtag, "This is real." This is a real offer or something like that. And even some of the venues aren't done. Like some of the things that the athletes are going to be competing at tomorrow are not finished. And then some of the other things they've made fairly unsafe. I guess they didn't hire the Amish is the problem. I guess some of the ski and the ski jump stuff, they've made the ramps way too steep. It's very dangerous. I guess people's skis are snapping at the it's way too steep, not off by a degree or two. It's more like a drop, a skydiving type of thing. Yeah, Shaun White backed out of one of the events after one of his fellow competitors snapped a collarbone. I think I'm going to focus on. I think it's a new event. It's a snowboarding slalom or something. And I don't know. I guess the course is basically a death trap. It's. I think you get going 600 or 700 miles an hour or something like that. And then there's trees and there's avalanche risk and. This could be an exciting Olympics.
Is there a thing, Russian Amish people?
That's a good question. Are there Amish in Russia?
No clue. I don't know why they would go there.
Well, it seems like it would be easier to live in a society that has less technology. It seems like the Amish would have it easier. They wouldn't constantly have this, the pressure to cross the line. You know what I'm saying? You know what I'm saying?
Can you just imagine a communist Amish person?
Isn't there some show on TV about the Amish Mafia?
Yes.
And then you have the other show, Vanilla Ice Goes Amish. That's my favorite show right now. I've been DVRing that. They're teaching him all sorts of good skills. He's learning how to build barns and feed horses, and like legit stuff. You think it's meant to be a funny show. How many of you have watched it? Nobody's watched Vanilla Ice Goes Amish? What are you people? It's actually like a legit show. They don't even do it as a joke. It's hey, this is what it would be to be an Amish person, and this is, they have a really good skill set. And they're teaching Vanilla Ice that skill set. Does everybody know who Vanilla Ice is?
Yes. Anybody.
What year was Vanilla Ice? Was everybody alive when Vanilla Ice was?
I don't.
When you had the MC Hammer Vanilla Ice showdown? You know, MC Hammer's a pastor now. I think he's at a Baptist church, Christian worldview.
Yeah.
Mark it. All right. So, anyways, are arrays bad? Is there a problem with arrays? Should we never use arrays again? When would be an appropriate time to use an array? Knowing that, well, you know a little bit about linked lists, but generally speaking, are there times when arrays are the correct tool? Because everything about programming or everything about problem solving is using the correct tool for the job, right? That's the whole MacGyver thing. Well, sometimes you're not using the correct tool, you're using what tool you have laying around, but what kind of problem would we solve with arrays? Well, when we need something to be fast and we know how big it is, right? Who cares about the memory and efficiency aspect of it if we need it to be fast? That's our trade-off, right? Okay, so arrays certainly have a place. It's not like when we introduce linked lists here that we're talking about the upgrade to arrays. We're talking about another tool that solves a similar problem but in a different way and has its own pros and cons. Make sense? All right, so what are linked lists? A linked list is a collection of nodes where each node has a payload that holds one or more values. So a payload could be a primitive type, a payload could also be an object type. Okay, so an object type obviously would be able to hold a whole bunch of values or something. All right, so a linked list is a collection of nodes. Each node is linked to another node through a pointer. So the punchline here is that nodes do not necessarily, oh, that's a hard word. Did I spell that right? Ha-ha! Nodes do not necessarily reside next to each other in memory. You might get a luck of the draw thing where a node gets placed right next to another node in memory, but the rule doesn't say they have to be contiguous in memory. So we create nodes as we need nodes. So another benefit of a linked list is that you do not, well, here I should stick with you do not need to know how many items are to be stored ahead of time. It's close enough for spell check. All right, so benefits of linked lists. Arbitrary size. We don't have to know how many things we're going to store ahead of time. We can just keep adding things to it, removing things from it. Don't have to rebuild it. Just, no. They have a lot of efficiencies that arrays don't. So we can say linked lists are very, very memory efficient. In fact, we can basically say they're perfectly memory efficient. They're as memory efficient as you can get with storing large amounts of data. Because to add one more thing to our list, we only need something. We only need a spot in memory big enough to hold a node, whatever that node is. Okay? We don't have to worry about contiguous memory. We just need some open space in memory big enough to hold one node. Make sense? Okay. So linked lists are very, very, very memory efficient. But they're also slow. So very memory efficient, but slow. Again, that's our trade-off. Okay? Remember we talked about arrays where we can walk arrays mathematically. We can do pointer math to walk through an array. We talked about that last class, right? Did we? Yay, nay, may?
Yes.
Okay. I told you I'm vegetable lasagna up here. Did anybody get that reference? Hopefully somebody got that reference. Old people? What's vegetable lasagna from? TV show quote. Had a recent reunion at the Super Bowl. Seinfeld. Oh, that was a decent answer. Red Hot Chili Peppers. Aren't they like 60 years old now? I don't think they're out. They're probably in their late 30s, early 40s. But I remember when they were like, you know, like 19 punk rockers, or is that what they call it? Is that what they're called? Punk rockers. It's so old. I want to know, what does that make you?
I know, old woman.
How old are you?
43.
Jeez. It's 7 years on me. That's almost. No, I was 9 when I first started programming. See, soon you'll start programming.
Yeah.
All right, so linked lists, very memory efficient. That's the big key. They're very memory efficient, but they're slow. Now, what's actually interesting is linked lists had a time when they were very popular. In fact, most of our data structures are built on top of linked lists. But they were, let's say, created at a period of time when memory was at a premium. That's less of a problem today, right? I mean, how much memory do we have in our computer? So we have a bunch of laptops in here. Most of you are playing, any of you playing something sophisticated video game-wise? Battlefield or anything right now? No. How much memory do we have in our laptops? 4 gigs? 12 gigs? Anybody have 12 gigs beat? That's a lot of laptop memory. Is it? It's an Asus. It's a gaming machine. You got the big old fans in the back. All right, I win. So I have 16 gigs of memory in my laptop. Who needs that in a laptop?
Well, you do if you want to have multiple things.
No, you don't. Not 16 gigs today. 3 years from now, maybe. But then I'll have, 64 gigs. Right? So I always got to stay, you'd rather have it, not need it, than need it, not have it. Oh, and by the way, the vegetable lasagna quote was from Elaine in Seinfeld. She had a quote about vegetable lasagna. At some point, there might be a quiz asking what is the best character in the entire Seinfeld series. There's only one correct answer.
Kramer.
No. One correct answer. I do like Kramer, but everybody likes Kramer. Correct answer is Jackie the lawyer. He came out during the Clarence Thomas thing from the OJ trial. There was one episode where Kramer opens up his own smoking thing in his apartment. Because there's some diner that they used to go to outlawed smoking. So he invited all the guys who were standing outside up to his apartment, and they were all smoking. So then he comes over to Jerry's, and he's all dark and crinkly and some of that. And Jerry's like, Kramer, what happened to your face? It's like, what do you mean? He looks in the toaster. It's like, oh, Jerry, my face, it's my twinkle, it's my allure, it's my livelihood. So he goes and sees Jackie the lawyer, and it's like, because he thinks he has a lawsuit against the tobacco companies, but he's burned Jackie a bunch of times. So Jackie's like, I've been wanting to get a piece of them for years. So comes in, and then they show the scene where the tobacco company's sitting there, and it's like your product turned this fine specimen into a horrible, twisted freak. And the lady's like, no, I feel Mr. Kramer depicts a rugged masculinity. It's like, rugged? The man's a goblin. That's the best character in Seinfeld, Jackie. Oh, yeah. Okay. So you think about all the things you're learning today. Linked lists, array, Seinfeld, Sochi Olympics.
seen Curb Your Enthusiasm?
Oh yeah.
Removable door handles.
Huh?
Removable door handles.
Yeah.
No, actually, wanting door handles.
Well, there was another one where someone tried to open their door and the
The
door
handles came off.
Yeah.
Wasn't they didn't have the back part. Only the front part came in.
Apparently.
All right, so linked lists really came about at a time period where memory was really at a premium. So being memory efficient was very, 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 very important. Now, does that mean that linked lists aren't needed anymore? No, because linked lists, the benefit of them being able to be arbitrary in size is a big plus. We don't have to spend a lot of extra CPU cycles rebuilding things like arrays. So even though arrays in their natural state are very efficient from a speed perspective, if we are adding things or removing things from an array, that requires us to literally burn down the house and build a brand new house with one extra room in it. Or burn down the house, build a brand new house with one less room in it. Okay, so adding stuff to arrays is quite expensive. Okay, we would never do that in real life. But if we knew exactly how many rooms we need in the house to begin with, arrays are good. Linked lists allow us to add and remove things passively. No big deal. Okay, so while their memory efficiency aspect might be less valuable to us today because memory is not at a premium, certainly the efficiency of adding and removing things in terms of having to rebuild the entire data set is still a benefit. Okay, so most database management systems are built on top of some twisted version of a linked list, some data structure that's based off of linked lists. And during this semester, we're going to be learning about all sorts of different data structures, and every single one of them uses a linked list or the concepts of a linked list as its base. Okay, so let me get rid of these slides because I don't know where they came from. Did I just kill two birds with one stone? It's a miracle. All right. So let's talk about the components of a linked list. So a linked list is based on top of objects. So we were talking about data structures beginning of last class, I think, where what's a data structure? It's a structure for holding data. And an object, by definition, is a data structure. It's kind of a less complex one because it's self-contained. So it's kind of the data structure that's built into Java. And it actually has a historical, the structure part of it has a historical significance in languages like C++ and C, specifically in C. So the history of this is this. So in the C language, we needed variables that could hold more than one thing, where each element had a unique name. That means arrays wouldn't work. So our early data structures, if you needed to hold 3 pieces of data, you might create an array that had 3 buckets. At bucket 0, you knew this piece of data was there. At bucket 1, you knew this piece of data was there. And at bucket 2, you knew this piece of data was there. But that's not very descriptive, right? You have to remember that bucket 2 has, maybe bucket 0 is the first name, bucket 1 is the last name, and bucket 2 is the social security number. Something like that. You had to remember that's where those things were, right? So there was a need for something that allowed us to hold 3 pieces of information, first name, last name, social security number. And in C, that was called a struct. Okay? So it was a struct data type. So a struct allowed us to create a single variable type that could hold more than one value. But that wasn't good enough for us, right? Why not? Why wasn't a struct enough? Struct, structure, get it? Haha. Why wasn't a struct enough? What did structs, what were they missing? This is the evidence of where C++ came from, why object-oriented languages needed to take over. Structs could have a single variable name associated with multiple values being stored, but what could they not do? Easily. When we think about objects, there are three things that make up objects. What are those three things? Fields, which are the variables, right? Constructors, methods. Methods kind of important. Reusable chunks of code that let us do cool things, right? Well, structs didn't allow us to use methods. Back then they were called functions or procedures. The word method hadn't been invented yet, apparently. That's an object-oriented term, method. In the C time period with procedural languages, methods that returned a value were called functions. Methods that did not return a value were called procedures. Before that, they just called everything a subroutine. That sounds cool, right? All right, so in the days of structs, so we're talking 1970s, even into the 80s, you easily could store more than one variable, given it a unique name. So you can say first name, last name, social security number. But you could not easily do this with functions. Kind of an upgrade to structs allowed you to create pointers to functions. So you sort of kind of could pull off the whole I'm like an object thingy. But you saw a lot of the wires. Remember, we get back to the procedural object-oriented languages where we have the telephone on the table over here where you see all the exposed wires. Okay, so structs were like, we can sort of kind of do this. We MacGyvered what we need here, but we really need something better. So that's where C++ came in and introduced this idea of objects, but pointers were still a major part of C++. Well, rightly so, because pointers are important. And of course, they don't exist in Java, even though we're going to be using them the entire semester. And we're also going to be using Java. But C++ introduced this idea of objects, and objects are a collection of values, fields, and methods. And then we have constructors for initially creating our objects. That's kind of the gateway drug into an object coming into existence. Funny joke. This came from my wife this morning. So last night she decided not to take the awesome cough medicine stuff they have her on for pneumonia that has, I don't know, like tons of codeine or codone or hydrocodone in it, something. And my wife's 5'4", like 104 pounds. So she really should probably be like on a child dose of this, but no. So she's been taking full doses that basically just knocks her out for about 24 hours. She could barely stay conscious, which I've enjoyed. And I've slept well because she's not up coughing all night, but she decides that she feels so out of it during the day, she's not going to take it last night. So she doesn't take it. And this morning she had a headache, and she's only been on this for like 5 days. So she's thinking, oh man, maybe I'm having withdrawal symptoms. I'm like, oh, you got to get back on the pipe. Yeah. So my wife has determined that she is now addicted to hydrocodone and is having withdrawal symptoms in the form of a headache and chills and.
That's a really addictive.
Well, the reality is she's really sick, and when she was all, hopped up on these meds and she was sleeping most of the time, she didn't realize how sick she was. That's the better state to be in when you're really sick, right? Let your body fix itself without you really being aware of it. It's terrible. So I got to get her back on the pipe, so to speak. Slip it into her Cheerios tonight.
So in other words, you're going to drug your wife.
Right. It's better for everybody. All right. So structs led to C++, which then led to the problems in C++ with the, hey, pointers are dangerous, led to Java, where pointers don't exist, sort of. So that gets us to modern day Java, where we have objects, and the object building block that we use for linked lists is this object called a node. What's a node? A node is a payload. This is variable that holds crap. So the payload of a node is the value we're storing at that bucket. That makes sense? In singly linked lists, so we kind of have two different linked lists. We have singly linked lists and we have doubly linked lists. We'll initially look at singly linked lists. So in a singly linked list, we also have a variable of type node, usually called next node. So we know about who the next node is. We're following the chain. These are our pointers, right? So each node knows who his next node is. Well, doesn't really know who it is, but knows how to get there. Okay? So the end of our linked list is the guy who's a node that has a next node that's null. There's end of the road. Make sense? The front of our linked list is a node pointer called head. Tells us the front of the list, the head of the list. Now, after we do singly linked lists, we'll look at doubly linked lists where we can go forwards and backwards. So when we do that, we'll also have a tail of the list that will point to the end of the list. And each node will also have a previous node pointer. Okay? So nodes are actually very simple very simple objects. So let's go into Eclipse here. All right, so I'm going to come in here. We're going to create a class. See, you see how my jokes, they actually transcend multiple classes without me even having to bring them up. All right, so we'll create an object here called node. That's this guy. And for our simple linked list, our starting point, we're going to have payloads that are of type int. We'll store numbers, okay? So our payload's actually going to be a primitive type. So we're going to say private int payload. All right. We'll also say private node next node. Now, interestingly enough, a node has a variable inside of it of type node. So be careful that you don't let your brains get into an infinite loop because it hurts. All right. So those are the two values that we will have inside of a node right now. Okay. And we need to create a constructor for our node. So we're going to say public node. Constructors always have the same name as the class name. This guy will take in an int payload as a parameter, and we'll set this dot payload equal to payload. So when we build a node, we pass it the value we want to hold, and it sets the payload equal to that, and we probably want to also initialize our next node to null. We currently do not have a next node. Make sense? So remember, the job of a constructor is to initialize an object. So what does it mean to build a brand new node? It means set the payload to something you gave it, and then also initialize next node to nothing, because currently we point to nothing. Make sense? All right, so that's what a node is in its most basic state. I'm going to go ahead and give a method here called display, so a node can display itself, just because that becomes helpful when we're walking through this and showing some examples. So we're going to have a node display itself by just showing its payload. Okay, so we'll say system.out.println payload. Oh, and I have to carry on what I was doing last semester. We'll always put this dot in front of it until we completely understand the this keyword. So let me ask you this question. Why do I not have to use this dot in this case? Why could I just say payload? We'll see if you understand the this keyword yet. Kind of like that commercial about the was it Cheez-Its? Whether or not the cheese has matured enough, and the guy has a little checklist. Yes? Go ahead.
Because it looks for the most local name of that variable, and since there is no local one, it goes out.
Okay, so if I just say payload here, payload is a variable. It's going to try to resolve this variable to its most local definition. So the first place it's going to look is locally inside the display method, inside the scope. Is there a method defined? Is there a variable defined in here called payload? There's not. So it's going to go one level out to the next most local scope, which is the global scope from our class. And that's where our payload is. So it'll find it without the this dot. Putting this dot is explicit. So we're saying, hey, don't beat around the bush. Don't look locally. It's this guy. Make sense? So by actually putting this dot, we've made it a little bit more efficient. But we're really talking marginally. Nothing to worry about in the big scheme of things. But we want to really understand scoping rules. That's why I use this dot for a while until we can rationalize that. Out of curiosity, how many of you think you understand the this keyword completely? Like intimately. I mean in the biblical sense. How many of you know that I think that's a Christian worldview point. Oh, I'm so bad. Okay, so in any case, what was I talking about? Oh, no, I'm done talking about this keyword. The cheese is not ready. No, right? Okay, so a node knows how to display itself right now. So we'll leave it at that for this second. I'm going to go into my driver class and we're going to get rid of our Amish guy here. What's he doing in a computer program anyways?
You put him there.
I like to
He's
put
probably
people
crying
outside of
and
their
trying
comfort
to
zone. I'm almost out of coffee. It's very sad. Okay, so anyways, we're going to create a new node. Node n is equal to new node, and nodes take in a integer payload as a parameter. So we're going to build a node that is 5. Okay, notice inside node here, here's the constructor. This guy requires me to pass it an int to build me a node. Okay, so right here, I'm going to build a brand new node. I'm going to pass him an int. I'll create another node, node n2 is equal to new node 7. Then we'll do system.out.println and system.out.println n2. So what will the output of my program be? Why is everybody just mumbling?
We don't want to commit to what we're saying.
Commit! What's the output of this program going to be? How many of you think 5 and 7? Arms way up. How many of you think 5 and 7? We need full voter turnout or we're doing push-ups. With me sitting on your back. So we got one person, 5 and 7. Okay, who thinks it's going to be 2 memory addresses? Who didn't vote? It's going to be 2 memory addresses. Why? What is n? Tell me everything you know about n. Ooh, almost spilled that. Don't all speak at once. What's n? It's a variable. N is a variable. What type of variable is n?
Node.
Yeah, it's a variable built for holding a node. Okay? What value does n hold? Holds a memory address. How do you know? The new keyword. So we know that n, or I should probably put this over here. We know n is a variable because this is how we define variables. Variables are defined by the type, followed by the variable name, optionally equals the value. So n's a variable of type node, and everything on the right-hand side of the equal sign is the value that we're putting inside of that variable. We know that value is going to be a memory address because we're using the new keyword. And the new keyword always produces a memory address. Okay? But what it's going to do is it's going to produce for us the memory address where the node that was built by this constructor is built. So somewhere in memory, we're building an actual node. We're building one of these guys. It's a house. It's a house that has a payload and a next node and all this crap. It has one bedroom. It's called display. It's a nice little property, beachfront, coffee front. So that's what's being built. This is where it's being built, and that value gets stored inside this variable. So the value stored in n is actually a memory address. So when I run this, I'll see two memory addresses. Make sense? Okay. Oh, sorry. I don't need the preload. What will the output be now? Here's the display method. Do you think 5 and 7? Okay, output now 5 and 7. Because the display method prints out the payload. Now I'm going to write a method in here. ToString. It's going to return a string. And we're going to return the payload as a string. Okay? So it's kind of a way to get payload as a string. Now I'm about to trick you. Nothing up my sleeves. I'm not wearing sleeves. All great magicians don't wear sleeves, right? Have you noticed they all wear sleeves? Except me. All right, so.
You do just hide it under your gut.
I do. That is true. That's where I hide stuff. I hate you.
That's the first time you said that anyway.
I know. At the gym, the towels don't go around me. So I just tuck it under my gut. And it just kind of hangs in the front. Oh, the life of a fat guy. Okay, so we're back to this. What will the output of this program be? What's n?
Variable that holds a memory address.
It's a variable. Holds a memory address. What's the output of this going to be?
Memory address.
Confident?
Yes.
Who agrees with them?
What did you say?
He thinks it's going to print out two memory addresses. Of course, it prints out 5 and 7.
That's what I was
I'm not paying you.
What changed? Oh, right.
Okay, so let's go and answer the why. So it printed out 5 and 7. The only thing I changed is I went into Node here and I added this little method called ToString. Okay, remind me, what is Node? If you had to give the vocabulary term for what Node is in the world of Java, what would you say Node is? In the beginning, we had structs, and structs had a problem. So we upgraded to what? Object-oriented languages, where now we call them objects. Okay, so a node is an object. See, that was a Christian worldview plus the Star Wars guy. What's his name? He was just on Big Bang Theory last week. What's Darth Vader's voice? Who's the guy? Earl Jones. James Earl Jones. See, that was a good Earl Jones impersonation, wasn't it? Did you ever watch Star Wars as an Amish kid?
Yeah.
Did you? People are messed up.
It's like super technology. What is that, like blasphemy?
It's not real if it's futuristic, right? I mean, that might not be even considered technology in the future. We could be using that.
At that point, they're using payphones.
Everything's like that. There's a time lag. Okay, so I created this little method in here called toString that returns the string representation of the payload. So the question is, by creating this one guy here, why did this now print out the values instead of the memory addresses? The explanation here is important. We learned about it last semester. Inheritance is involved. Help me out here. Who does node inherit from? There's something invisible right here. I told you I'm a magician.
Objects.
An object. So there's that guy is right there. Okay? Extends object. So a node gets everything that's inside the object class, because that's how object-oriented languages are built. There's a hierarchy, and everything starts from a base object that says an object is this. Okay? So, what's println? An object-oriented vocabulary. What is println? What kind of animal is that? It's a method. How do you know?
It has
Parentheses. Well, this isn't rocket science, people. It's a method because it's got parentheses. If it didn't have parentheses, then it's a field or variable thing, right? With parentheses, it's either a method or a constructor. And it looks like it's a method. How do you know it's a method, not a constructor? No new keyword. That guy's a method. Okay. So, it's a method being called by who? Whoever this dude is, right? Do you think it's an instance method or a class method? I don't think you can absolutely 100% answer this with 100% confidence, but I think with 99.7% confidence you can make a pretty good guess. Is this a class method or an instance method? Okay, why are you wrong? Why did you say class? Let's go.
Because it was a 50-50 chance. Because you were giving it a variable to do something with.
What?
Like the only thing that was going through my head was the oven.
Coffee.
I really wish I had a picture of that face.
I'll continue. I wasn't paying attention.
I know. The only thing I could think of was the oven example that you gave last semester.
What example?
The oven example.
Oven.
Of class methods.
Instance of. What? The instance of operator?
Maybe.
Oven? What?
Like pie ovens. You don't even remember your own example?
Well, help me.
Like
I don't remember what I had. I mean, I taught a 4-hour class last night. I don't remember what I had for breakfast yesterday.
Your example.
Vegetable lasagna, remember?
Yeah. your example is that you have an oven, and you only need one oven to make a bunch of pies, and that was your example for a class method, if I remember correctly.
I'm pretty sure I used the example of a factory that you send. Yeah, whatever.
Yeah.
I'm with you now.
I think you used both.
Right. I do like pie.
So that was kind of what I was
Sounds
thinking of.
delicious. All right. So what does that have to do with why you thought this was a class method?
No clue. It was what was going through my head at the time.
Oh.
And
I thought you were going to say something much smarter than
no, I just took a shot at it.
that. Okay. So why is this an instance method? How do you call instance methods? Using an instance of the class in which the method was defined. Now, we don't necessarily know what class this was defined in yet. There's not enough evidence here. We can go and look it up, and we will in a second. But who's calling the println method? This dude. Out. Now, why would you suspect that's an instance of a class rather than a class name itself?
It's not called by driver.
No. Because I could say character dot to uppercase, and character is a class. To uppercase then would be a class method, and it's not driver. So how, from what I have highlighted right there, the bluer highlighted. I see how everything kind of looks highlighted, but the out that I have extra highlighted. Why would you suspect that's an instance of a class rather than a class name itself? Yeah. Abe, yep.
Because it's blue. And
We need to get you a top hat.
the fields are blue.
Oh, because you're doing this on color? You're serious? Oh, okay. I suppose I can give you that, but that's. Let's assume we were looking at this in a text editor that did not color code crap. Okay? Why would you strongly suspect that this is an instance of a class rather than a class name itself? There's a naming convention in Java that should give you a strong suspicion here. It's lowercase. Class names almost always begin with an uppercase letter. In fact, all classes that I can even think of that the makers of Java wrote all start with capital letters. And since we didn't write anything else in here that broke that naming convention, out is very likely a instance of a class rather than the name of a class because it's all lowercase. Because it starts with a lowercase letter. Make sense? So then, what is out? We have a bunch of things going on here. So in object-oriented vocabulary, what is out? It should be almost instantaneous. You only got one option this guy can be. Is it a method?
Field.
It's a field. How do you know?
Well, not a method or construction.
There's no parentheses. So it's not the other two. Must be a field. Okay? So out is a field. Variable of some type. We can't necessarily tell you what type it is right now. I know what type it is because I've looked it up before, but I'll show you here in a moment. But it is a field of some type.
Should have just gotten both of your answers by my answer.
I guess I can't argue. But my answer is more instructive. Okay, what system? Class name. How do you know? Besides it being highlighted in gray. How do you know this is likely a class name? Capital S. Okay? So system is likely a class name. It's calling one of its fields called out. And that field, which is a variable, an instance variable, is calling an instance method called println. Okay? Make sense? Now, remember where we got to here. Before we saw this little magic trick, the exact same code in here printed out 2 memory addresses, but right now it prints out 5 and 7. So let's go to the documentation. So I'll go to java.sun.com. Let's hope the internet's working. Go to Java SE. Java APIs. Click on one of these. It doesn't matter. I'll make this a little bigger here. I'm going to go into, it'll actually be in no, it'll be java.lang. This will be good enough. So go into actually I need to do it over here. Go into java.lang, so we're in that package. Why did I choose to go into java.lang? Go back to the code. I'm in driver, something else invisible up here. There's lots of invisible things in Java. What is up here that we don't see?
Import java.lang.
Import java.lang. It'll actually be java.lang.star, like that. This says import everything that lives inside of java.lang. This is the core Java programming language, java.lang. So it's automatically imported for us so that we have access to all the core Java stuff. Okay? So because it's automatically imported, we don't actually have to write it to be imported. Back to the documentation. So I selected java.lang here. I'm going to scroll down to classes, and we're going to find a class in here called system. Here's system. Okay? Click on that. Now, what do we expect to find inside of system? Go back to our code here. What do I expect to find inside of system? A field named out. Correct? So here's my field summary, and there's a field name out right here. And what is out? It's a print stream. Okay? We don't necessarily know what print streams are, but we can click it. See? Color coding. Okay. So we can click on print stream. So we're going to go into this.
It's highlighted in blue.
It is highlighted in blue. Okay, interesting quiz question here. I'm about to trick you. Now we said this is an instance field, right? How do we call instance methods? We call instance methods using an instance of the class in which they were defined. Correct? But this guy has the word static out front. What does that mean? Does having static out front here mean that this is not an instance of the print stream class? The answer to the question is no, it does not mean it. I promise you, this is an instance of the print stream class. What does having static out front here indicate?
It can be if you want to.
No, it actually has nothing to do with this part. It has nothing to do with print stream. Having static out front means that this guy is a class member, which means that this variable out belongs to the class system, not individual instances of the class system. So that means that this variable only exists once. We have a variable of type print stream named out, and it exists one time, and it belongs to the system class. So we access it by saying system.out. That's how we access this field. But the field itself holds an instance of the print stream class. So the value in that field is an instance of the print stream class. But the field itself exists one time. We don't get a copy of it for every instance of system we create. It exists once. It's owned by the class itself. That makes sense? The difference there? Okay. When we have methods that are class methods, like this method, clear property, whatever it does, okay? This method's a class method. It dictates how we call that method. It doesn't change the fact of whether or not it's a method, okay? It just tells us how we call it. So all methods are methods. Some methods are called with class names. Other methods are called with instances of classes. All fields are variables. and variables hold values. There's no way to hold a hard-coded value like that. So in order for out to hold the value of a print stream, it must hold a pointer, a memory address, which points to an actual instance of print stream. That's the only way for a print stream to exist and be stored in a variable. We could not do something like this. System S is equal to system. I cannot store a class name inside of a variable. Does that make sense? So variables always hold instances if they hold objects. Always, 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 always. A static variable dictates how we call that variable, how we access that variable. If it's a class variable, we access that variable using the name of the class in which the variable is defined. If it's an instance variable, we access it using an instance of the class in which the variable was defined. Make sense? Did I make that clear? Make it worse? Are we still thinking about pies? Okay. So all this static here tells us is how we access this field. We must call this field using the name of the class in which the field was defined, and the name of this class is system. So we say system.out. All right, so now I'll click on print stream. We'll keep going down the rabbit hole. And after I click on print stream, what are we looking for? A method called println, right? We expect that to be an instance method or a class method? You already told me the answer. It's an instance method, right? Because we're calling it with an instance of the print stream class. So I'll click on print stream. Scroll down to the methods. And we have a println method here. We have another println method. 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 What's it called when you have more than one method with the same name but takes a different number and or type of parameters?
Polymorphism.
Polymorphism. So this is a real life example of polymorphism. We have a class called printstream that has a bunch of instance methods. That is methods that don't have the word static out front. Okay, a bunch of instance methods. Each of these methods returns nothing. They just do something. So in an older language like C, these would be called procedures. They don't return a value. They just do something. So the println method takes no parameters, just kicks us down a line. Then we have a println method that takes a boolean, a println method takes a char, a println method takes a char array, a println method takes a double, a float, an int, a long, an object, a string. Which version of the println method are we calling right here? The one that takes an object. How do you know? Because n is an object, right? So when I call that method, the Java runtime environment is going to figure out which of these printlns you're talking about. Are we talking about the one that takes nothing? No, we passed it something. We talking about the one that takes a boolean? No, what we passed is not a boolean, so on and so forth. Are we passing it? Are we calling the one that takes an object? We are. So we're calling this one because we're passing it a node which is an object. How do we know it's an object? Because we saw the invisible extends object here. We use one of those black lights. Make sense? Reveal the extends object there. So we go into this version of this guy. The println method that takes an object, prints an object, and then terminates the line. This method calls the first value of for the string. I'm going to kick this back here. We know that all objects inherit from object, correct? So I should be able, let me kick back one thing here. I should be able to go right here and view what a generic object is, correct? So I'm going to click on that. Here's the father of all objects. All right, so object has a constructor that does nothing. We have a whole bunch of crap in here. And we have this one method. ToString. takes no parameters, returns a string, and this guy returns a string representation of the object. What does the default toString method do? It returns a string representation of the object. So according to Java, a string representation of an object looks like a weirdo memory address. That makes sense? So, as proof here, when I say n, system.println n, that's just like saying system.println n.toString, correct? So are these two lines identical now? In terms of, are they calling the same thing now? Do we understand how toString works? Okay, tell me why these are not the same lines. I'll give you all the information you need. Where are we at here? Everything you need is on the screen.
Now it's going to print of string instead of object.
It's calling this version of println now, the one that takes the string as a parameter. Because now we called upon n's toString method that we didn't write, but we inherited from object. And the toString method boils down to a string. So what we have here is we have this guy right here ultimately becomes a string. Now, are strings objects? They are, but they're strings first. That make sense? Okay, so strings are objects because whoever wrote the string class at the very top, they're going to have an invisible extends object. And I'll prove that to you here. Click on string. Here's java.lang.string. Who's its parent? Java.lang.object. So you can see the lineage of an object at the very top where it shows you how many things. That make sense? All right, so this line right here actually calls the string parameter version of println. This guy here calls the object parameter version of println. But what does the object parameter version of println do? It just calls the toString method of whatever object you passed it. That make sense? As an example, I could write my own toString method, and I can return this dot toString. That's what the default toString method does. So I literally wasted my time here. But what am I returning? I'm returning the string returned by the toString method that we've written inside this class. Why do we have that problem? We call the toString method. What does the toString method do? Well, it calls the toString method. What does the toString method do? It calls the toString method. What does the toString method do? It calls the toString method. What does the toString... So I'm going to explicitly call my parent's toString method. My parent is object. Now when I run this, we get our memory addresses. Who did we get toString from? We got toString from our parent. Now, if I call this guy toString2, then I can say this dot toString, because we indeed got a toString method from our parent object. So when I'm out here and I call toString2, what does toString2 do? toString2 calls the toString method that we did not write inside here, but that we got from our parent through inheritance. So we'll see the same output. That make sense? Okay. So, inside of PrintStream, we have a whole bunch of Lin methods. We also have a whole bunch of print methods. These are the ones that don't do a carriage return at the end. And we have one of these for every single primitive type, as well as strings, because strings are kind of specialty things, right? They're not a primitive type, but they kind of act like a primitive type. So we have a special case for strings. And I've said last semester a bunch of times that Java is a string-based language. Okay? So we have a special version of this for strings. And then we have our catch-all for all other objects, whether it's things built into the language or things you built yourself. Every other object we'll call this version of println. And what does it do by default? It calls the toString method that it's guaranteed to have because it got it from the parent object which is object. So you're guaranteed to have the generic toString method that just boils down to the memory address looking thing, unless you write your own, which we did here. So if we write our own, and this guy must return a string, so I'll have to concatenate my integer payload onto a string to build a string out of them. So that's the string version of my payload. So since I wrote my own, I overrode the one that I got from my parent. Does that mean the one from my parent doesn't exist? It still exists. But just like variables get resolved, when this guy calls the toString method, when he calls this toString method, it's going to find the most local definition of toString. Make sense? And where's it going to look first? It's going to look for an instance method inside of node to find the toString method. And does it find one? It does. So it stops looking. Make sense? So this guy's going to display now the payload. But if I want this to be creepy, I can say super.toString concatenated with maybe a colon, concatenated with the payload. Here, let's put a, and now let's do this. Let's put a little arrow. That looks awesome. So now when we print it out, we'll get the memory address followed by an arrow followed by our payload. So that proves that the parent's version of toString still exists. We just overrode it by having a more local definition of it. But we actually utilize the parent's version of it inside. Kind of makes sense how this is all gluing together now? Okay, so we'll come back next time and we'll finish talking about nodes. You'll have a linked list assignment that I'll give you on Tuesday. All right, I will see everybody on Tuesday.